we've got just one more theorem about limits in this section. So one more video, and this one's kind of fun. To be honest, we don't use it very much, but I like the name. So this one's either called the Squeeze Theorem, sometimes it's called the Sandwich Theorem. And the theorem says if we have three functions, and f of x is always less than or equal to g of x, which is always less than or equal to h of x, okay? So f of x is always the smallest function, g of x is always in the middle, and h of x is the biggest one. So if we want to use this sandwich theorem, use this analogy, f of x and h of x are the bread in the sandwich, and g of x is I don't know what kind of sandwich this is. Let's make a grilled cheese sandwich, okay? This is the cheese. Or the peanut butter and jelly, whatever you prefer. Okay, so what this theorem says is if you have this sandwich of theorems, and if the limit of the two pieces of bread as x goes to a, so the limit as x goes to a of f of x, and the limit as x goes to a of h of x are both equal to the same thing, they're both equal to L, then the one in the middle, our cheese, that limit also has to be the same because it's always in the middle. So if the bread is squeezed together, has the same limit, then the limit of the middle one has to be the same. So let's draw a picture of what's happening here. So we have our coordinates, okay, and so let's say this is h of x. Well, let's pick an a first. So this is a, and let's say this is h of x. So h of x is always going to be above them, and we know the limit is equal to L. So we're saying whatever value that is, the y value is L. And let's then draw f of x, so our other piece of bread. It could be doing any number of sorts of crazy things, but we know its limit at a is also L. That it's like that. Okay. And then what we're saying, all this theorem is saying is if g of x has to be squeezed in there, and these are actually touching, then no matter what g of x is doing, it's always in between there. That means at a, it also has to be at L. Okay, so we're assuming it's squeezed in between there, and that at a, h of x and f of x are the same thing, which means g of x also has to be there. So these are some pretty specific conditions that, you know, you have these three functions that are lined up like this always, and that the limit for the outside ones are the same. So we're going to try this one. It says use the squeeze theorem to find the limit as x goes to 0 of x squared sine of 1 over x. Okay, now the reason that we can't just find this limit without using the squeeze theorem is if we plug in 0 for x, we'd have sine of something that's undefined. Okay, now we're going to have to use a rule here that you should remember from trig. So from trig, or pre-calc or whatever you took, you should remember that for any value, sine of any theta or any value, so including here 1 over x, sine of x is between -1 and 1. So what this tells us to set up our sandwich that, I don't think there's an h there, that x squared sine of 1 over x would always have to be between, if we plug -1 for sine over x, then we'd have negative x squared. And if we plugged 1 in, we would just get x squared. So if we think about the theorem up above, this would be our f of x, this would be our g of x, and this would be our h of x. So to use the squeeze theorem, or the sandwich theorem, we have to show that the limit of these outer two as x goes to 0 are the same. And if we take the limit as x goes to 0 of negative x squared, well, when we plug in 0, we get -0, which is just 0. And when we do the limit as x goes to 0 of x squared, we also get 0. Okay? So since these two limits are the same, and this function's always in between, we would say by the squeeze theorem, or you could say by the sandwich theorem, we would have to know that the limit as x goes to 0 of x squared sine of 1 over x is also equal to 0. Okay, so to use the squeeze theorem, you use two functions that would always be on either side of it, and you would show that those limits going to a value are the same.